Assalamualaikum. My name is RAIHANAH binti ROSLEE. My metric number is AA190544.
Assalamualaikum. My name is Izzah binti KHALID. My metric number is AA192058.
For lab activity 1, latching. This is a ladder diagram for lab activity 1, latching. When the I1 is pressed, the circuit will be normally closed position. The relay coil will be energized and become close contact. The fan turn on. When we switch off I1, the fan still on because the current is flowing through the relay contact. But when we press I2, the circuit changed from normally closed to normally open circuit. Thus, the fan turned off.
Okay, let's move to lab activity 2, task 2A, timer.
This is a ladder diagram for lab activity 2, task 2A.
The lamp turn on immediately and the fan is still off even we do not press the push button I1. When the I1 is pressed, the circuit will be normally closed position. At the same time, on delay timer will start counting for 5 seconds and the fan will on. After 5 seconds, the lamp turn off as the on delay timer contact change from closed contact to open contact. After we switch off I1, the off delay timer start counting for 10 seconds. The lamp and fan turn on because the on delay timer contact and off delay timer contact are changed from open contact to closed contact. After 10 seconds, only the fan turn off.
Now, task 2B. This one is a ladder diagram for lab activity 2, task 2B. When the I1 is pressed, the circuit will be normally closed position. The relay coil will be energized and become close contact. The lamp turn on automatically. At the same time, timer start counting for 5 seconds. After 5 seconds, the fan and buzzer turn on. Same goes to I2. This is because I1 and I2 are connected in parallel and it is in normally open circuit.
Okay, lastly is lab activity 3 about counter.
This one is a ladder diagram for lab activity 3.
I2 is counter button. We set the counter to 5. After 5 times click of counter button, the buzzer will turn on. I1 is reset button. We start counting 5 clicks of counter button. Just like before, the buzzer will turn on after 5 clicks of counter button. I3 is direction button. The function of direction button is to count down the counter. If the counter less than 5, the buzzer will turn off.
So for the observation, question 1, state the IP address, subnet mask and gateway for your PLC unit. So the IP address is 192.168.0.0.0 and 003, while subnet mask is 255.255.255.0.0.0. For the gateway is 192.168.0.0.0.0.0. For question 2, state the actual number of input and output available at the Siemens logo PLC base unit. So the answer is the actual number of input is 8 and the number of output is 4. So this is a picture of our PLC. This one is the IP address, the subnet mask and the gateway for PLC unit. Next, for the observation number 3, state the address of the input switches. The address of the input switches are I1, I2, I3, which is represented to push button 1, push button 2 and push button 3 respectively. For observation 4, state the address of the output lamp, buzzer and fan. The address of the output lamp is Q1 while the buzzer is Q2 and the fan is Q3. For the observation number 5, how to reset the timer in lab activity task 2B. The answer is, to reset the timer in lab activity task 2B, we need to press PB1 or PB2 once again. Observation number 6. How do you set the counter to count up and count down in lab activity 3? In lab activity 3, to set the counter to count up, we need to press PB2 for 5 times. Meanwhile, to set the counter to count down, we need to press PB3 and then press PB2 again. For observation number 7, explain what happened to the output buzzer when the counter count out more than 5. The output buzzer turn on when the counter reach 5 times and still turn on even more than 5 times. Observation number 8, explain what happened to the output buzzer when the counter count down less than 5. The answer is, the output buzzer doesn't make any sound, which is off when the counter count down less than 5.
Okay, for the question 1 is to discuss the importance of latching in ladder diagram. Describe an actual application that implements latching. So the answer is, the importance of latching in ladder diagram is it produces self-maintaining circuit. It means that after the output is being energized, it maintains that state until another input is received. For example, in this diagram, we will see that input A or PB1 in normally open push button, while input B, PB2 in normally closed push button. When the input A contacts close, there is an output. However, when there is an output, another set of contact associated with the output closes. These contacts form an OR logic gate system with the input contacts. Thus, even if the input A opens, the circuit will still maintain the output energized. The only way to release the output is by operating the normally closed contact B. Okay, next, describe an actual application that implements latching. So, for example, it is one of the application of latching diagram in Mitsubishi machine. Another example, if we use latching diagram in industry, is emergency button. It is to shut down the operation machine in industry if anything happen like burning. Okay, for the question 2 is, explain what happens when the inputs are connected in parallel. Okay, the answer is, when the inputs are connected in parallel, the circuit will be formed an OR logic gate system. Okay, for the question 3 is to explain what happens when the outputs are connected in parallel. So the answer is, when the outputs are connected in parallel, the circuit will form an AND logic gate system. It means that either all outputs will turn on or off. Okay, lastly is for the question 4, discuss the importance of PLC in industrial application. PLC has a robust construction and unique functional features such as sequential control, ease of programming, timers and counters. PLC also easy to use hardware and reliable controlling capabilities. It is designed to be enormously robust, so it could withstand harsh industrial environments such as extreme temperatures, vigorous vibration, humidity, and electrical noise. Next, it also tasks to control and monitor a very large number of sensors and actuators. It is also to improve the process of any industrial activity requiring control parameters.
That's all from